Okay, welcome to the evening of Python coding. It's part of the Austin Python meetup. We do this every third Tuesday of the month. Now during COVID time, we're doing it virtually. We usually show a demo in this meeting, and today I'll be showing the demo. My name is Jacob Barhak. I'm a computational disease modeler, and I'm going to talk about Dusk. Dusk is a library that helps you uh, parallelize things in Python. So I'm going to start the presentation now, and hopefully the recording will catch all of this. Okay, and I'm now presenting, so let's start and find the first thing about Dusk. Now this is PyData Global. Sorry, I've been showing so many things that I need to find it. So you will find the demo on the link, and I'll show you some information here on the screen so you can copy. This is the Dusk demo. You'll find it here on GitHub. I'll just, and you can see this is the evening of Python coding. You'll find this information here. This is how you reach the Dusk demo. You'll see some README, how to install it, how to use it, and some examples, and we're going to show it in the video eventually. And it's all free. You can use it. And this is the actual demo I'm going to show you. This is this code. I'm going to show it in a little bigger font so you'll be able to see. It's the same thing. I'm just showing it within the editor. But first, let me show you what Dusk is. And Dusk, this is the website. It's a project. I believe it's supported by NumFocus, but many open source developers around the world work on it. I know some of them personally, but the team changes every once in a while. You can find it on GitHub. Basically, what it does, it allows running things in parallel in Python, but it also gives support to actually do some computations. It supports things like working on matrices or working with data frames in parallel, and also have some machine learning applications. Scikit-learn is a machine learning library. And there's some start examples how to use Dusk here. I'm not going to go over them. I'm going to just show you how Dusk works in the demo. So it's a short demo. It will take us about 15 minutes to go through it. I'm going to show it to you in two ways. Dusk in the regular way and in the distributed way. So to start Dusk, you first have to install it. I usually recommend using Anaconda and then Conda install Dusk and Dusk distributed. You'll need those for the demo. I'm going to talk about the distributed part later, but for now, they won't be that different because on my machine I have only one machine. So the distributed part is not that important for now. On one machine, you don't need the distributed generally, unless you're doing something very special. So on my machine, I have 4 cores and 8 logical cores. I'll show you, this is my system, and the CPU is 8 cores. So I'm going to show you all the things working on this machine. Currently, you see the machine is not really working. It's like most of the time it's idling. The cores are not loaded, and if I have a computation, then it will take quite a while. So if I have a computation that I have to repeat, let's say I want to count from 1 to 10,000, and I want to repeat this count 1,000 times. This is what what I want to do in life in this program. So if I do this serially, I count from 1 to 1,000 to 10,000, or to a random number to 10,000, and each time it will do the count, and then the next time I have to start again. And if I use only one CPU, it will take me a long time. But if I have 8 CPUs and I do the counting on each of those, then potentially I can increase my speed by 8 times. This is what Dusk is for. It makes it easy for us to do that. So let's look at the program. And I'm gonna, since we have true beginners in Python here in the group, then I'm gonna show you some very basic things. Like at the beginning, I import the libraries, meaning all the libraries I'm going to be using. So Dusk and Dusk distributed. I'm using subprocess here. Generally, you won't need it with Dusk. Here, the way I coded it is funny and it has historic reasons. You'll be able to do it without. And I have to admit someone else. Here we go. Okay, sorry about that. So next, in Python, usually we encapsulate the script in an if statement says if name equals main. This differentiates between libraries and non-libraries. You'll see this is common in Python, and everything else underneath is going to be executed when I execute the script. So when you run Python and then name the script, everything underneath this will be executed. So the first thing I do is I create a temporary directory. Here I call it task demo temp. I'm going to do this with a try and except clause. First, I try to create the temporary directory. If it's successful, then it will print temporary created. If it's not successful, meaning usually it means that the temporary directory already exists, then it will tell me that it already exists. This is the try except statement. It will try to execute the command. The command is part of the OS library. It comes with Python. It's one of the core libraries in Python. And it addresses the operating system and asks me to create a directory for me. So once I've done that, now at this point, I know I have a directory under where I am that has the name Dusk demo temp. After that, I will do some things related to Dusk. So first, we'll talk about clients later. For now, I have no clients. And I'm going to repeat, I want to count from 1 to 10,000, actually to a random number from 1 to 10,000, 200 times. So this is like my defaults. However, I want the user to be able to change those defaults through the command as command line arguments. This is why I use the sys command here, the sys library here. And sysargv is a list that holds all the arguments when I invoke the program. And if the list is larger than 1, always the first element in the list is the name of the program. But if it's larger than 1, then I say, okay, the client name is the first argument. And then the repetitions, if there's more than 2 arguments, the repetitions will be the second argument, but I convert it to an integer. So
second and third, right?
Excuse me?
You mean the second and third argument, right?
If I need a second or a third.
No. You said sysargv1 is the first, but isn't that the second?
Yeah. So in Python, this starts with 0. So right. argv0 is the name of the program. It's the first element of the list.
No, I got it. I'm just saying that you said that the sysargv1 was the first, but it's the second. It's okay.
You lost me here, but I'm just checking. I'm just checking that the client name is the first argument after the name of the program, and the second one is the number of repetitions. If they exist, if they don't exist, I stick with the defaults. So far, we're okay. It's fairly common. If you have questions more, then we can look at this. But let's continue with Dusk. This is why we're here. The next part is I'm looking at the client name. If the client name is none, I do nothing special. However, for the distributed part, if I define the client name, then I have to point task distributed as that client. We'll talk about why we need this later on. For now, ignore it. For now, the client is just Dusk doing computations for us. It's more complicated than that, but it's good enough. So in Dusk, one of the things that you can start thinking about it. When you run things in parallel in Dusk, they might run on different environments, meaning different computers. Dusk allows you to distribute your computation to different computers. There, the system is actually maybe totally different, and you might be working on a total different directory name. Because once you invoke this, it doesn't pass your current system, like the current directory, doesn't pass to the other computer. So to do this, you have to figure out what is the working directory. So I asked the operating system, what is my current directory? And you see this working there here. Later on, we will use it when we run computations on other computers, or even on this computer, we'll set the working directory so everything will be uniform. So if you run Dusk on multiple machines, you want to all the time run it such that it always sees the current working directory. So now we're getting to the point of doing things with Dusk. Now, the program with Dusk and without Dusk will be very, very similar. Yes.
Someone asked, the working directory is a shared directory on a network?
If you are working on a distributed machine and you need those files, it should be shared. For example, when I run my simulations, on disease modeling simulations, when I run it on multiple machines on the cloud, for example, I make sure that there's a shared NFS directory, but it's always with the same name on all the machines. And then I work only on from this working directory, because especially if you need to work with files. If you don't work with files, you don't need that. Dusk will do things for you without looking at the files. Think about it. The differences between different machines usually don't, this Dusk doesn't care about them. If it's a simple Python computation like adding two numbers, you don't care on which working directory you do it. But if you write files and you want them to be visible by all machines, you should have a shared working directory. Or you don't have to, but then you have to somehow transmit the information back. It becomes complex at some point. So for now, let's just think about it as a good practice. Good enough? Did I answer?
Yeah, Jacob, that answers. Thank you.
Thank you. Good. So let's continue. I defined some file names. I'm going to run, the way I'm going to do this demo is very, very funny. I'm going to write a script, a batch file, that will just do echo commands. We're going to go this later. And then I'm going to execute that script as a process. And I'm going to ask Dusk to do this many, many, many times, 200 times. And each time this process runs, I'm going to record the output, I'm going to record the standard error, and I'm going to record, it's a batch file. By the way, I'm doing this in Windows environment. You can do very similar things on Linux environments. Very simple, the same program should work with very, very small changes. I'm showing it on Windows, but the same thing should work also on other systems. It's not such a big deal. Well, the next thing I'm doing, and by the way, what I'm doing now is I'm running map element as a function that creates one computation. And our computation here is start and echo all the numbers 1 to a random number that gets to 10, up to 10,000. So it's a very funny thing. We're just trying to count up to 10,000 here. It's a very simple demo, but I'm doing it in a weird way. The reason I'm doing it in a weird way is because I want to show you some other cool things to deal with Dusk, like the directory and stuff like that. How to do it properly. So here I just defined all the files and I open the files. Later, I generate a random number. This is from the random library. It will give me a random number. And I'm going to create, for each entry from 1 to this random number times 10,000, and I'm looking at the integer, I'm going to create a script, and the script will be echo that number. I'll show you later that script, how it looks like when it runs. Notice it will never reach to 10,000, because if you get its range between 0 and some number, or even 10,000, it will generate numbers from 0 to 9,999. However, here I'm also doing it until a random number, so it will be less than 1,000, 10,000 most of the time. So, and remember, after I did the echo, I put a new line in the script. So now I have a batch script that says echo 0, echo 1, echo 2, up until echo, let's say 3,000 or 3,010, depends what the random number was. I create that script, I write it as a file. I already opened the file, I write the script, and I close it. Now I exist that script, and then the next thing I'm doing, I'm calling sub process call, and I'm telling it run that script as a process, and here's the std error, and this is the std out, those files that I defined, and run it as a shell. This means it will run, Python will invoke a new process and run that script that I created. Now, usually you won't use Dusk for things like this, but here I'm trying to show you parallelism in a simple way. And there's also historic reasons for why this demo is written this way. So just bear with me, and I'm showing you some other things. Feel free to ask questions. At the end, I close all the files, and I return the name of the file that was generated. And notice, map element has a run number, just like I'm going to execute it 200 times, so the run number says the number I'm executing it. So the first time will be 0, the second time it will be 1, and 2, 3, up until 200. Good. So now I showed you how I count once from zero to a number, random number, up to 10,000. However, where is Dusk? I just showed you how I do this. Dusk, the only change when you want to parallelize things with Dusk is just add this decorator on top of the function. This will do the magic. We'll talk about this magic in a second. But Dusk delay says that this function does not execute when it calls it. It goes into a queue of things to be executed somewhere in the future, and it is delayed. So I did this, and now I ran 10,000 of those, 200 times I counted from 0 to a random number until 10,000. Then, typically, when you're doing parallelization, you collect all this data somehow. It's called sometimes MapReduce, and therefore the names here of the functions, map and reduce. A map operation will go over every element of the computation and do the computation. It will map some function on the computation. This is why it's called map. A reduce will take all the array of computations, meaning all the 200 times that we repeated the same number, and we'll do some operations with it. Here the operation is very simple. I'm just going to collect all the names of the files, and I'm going to output them. The way I'm doing it is I'm looking at the array, and for each entry in the array, I'm concatenating it into a string, and the string I'm getting the name of the file. Remember, map will generate at the end, will return the file name, the output file name, and reduce will concatenate all the names of the file name. So you should have 200 names here at the end. Then eventually reduce will also create a summary file which has the outputs of this string, and it will give you back the summary file name. Now notice, reduce itself also the delayed reduce, also I decorated with Dusk delayed. With Dusk delayed will be able to understand that this should not be executed until I actually asked Dusk to create executions. It just files things. It says, oh yeah, I know I have to do this somewhere in the future. Think about someone who's like very busy, that is getting all the sorts of tasks to do. So some of the tasks, generally that person will get the task all the time. But think about that person having 8 people to help him. What Dusk delay does allows him to collect all those tasks, say thank you to the people giving him the task, and then assign those tasks to the 8 people who help him. This is what Dusk does. And then all the 8 people are helping him. But all of this has to do, first the person has to know all the tasks that have to be done. This is what Dusk does. So now let's look at actually what's going on. And First, we define the functions, meaning the map functions that we have to execute. I define the compute array. I'm using list comprehension in Python for people who haven't seen this before. Basically, it's a for loop. Well, for each element in the for loop, I'm applying map elements. Notice, without Dusk, the system will just, each time it will receive that in the for loop, it will execute immediately. However, when Dusk is delayed, what it will do, it says, oh yeah, you know, I have a map element function that I have to execute somewhere in the future. Yes, good. I know that. Continue to the next element in the loop, and the compute array will become a list of things to become in the future. Dusk will take a split second to actually execute this command. Otherwise, without Dusk delayed, this will hold for a long time, and all of those things will be executed on the CPU serially. If I remove those lines, the Dusk delayed. With Dusk delayed, it'll just basically create an array of computation, and then after the computation was created, then I pass it to the delayed reduce. Notice, delayed reduce accepts as an argument as the array of things to happen, and then it calculates the reduction. Now, normally without the Dusk delayed, it will wait until all computations are done and then go over and concatenate that string over things that have been computed already. However, when you're using Dusk, Dusk kind of masks everything. It says, you know what? I know that in the future you will compute an array. I know that. I know that I have to reduce it. So it just registers to itself, and we have to execute on that on that array that will come in the future. I will have to execute that delayed reduction. Before Dusk, when you used to do things in parallel, you have to define explicitly that this task waits for other tasks. I'm talking about old systems like Torque, PBS, Slurm, some clustering systems they used up until today in supercomputers and some other cases. However, now with Dusk, no longer you have to do all those things. It's much, much simpler. So now, since it's delayed, the system Dusk will tell you, oh, out, I know that out will be computed at some point. Now, we actually ask Dusk to start the computation. Now, normally, out, if without Dusk, it will not have the compute member function or compute method. However, Dusk, since it knows it will do something in the future, it allows the user to actually execute the computation at any time. So you can actually ask now, compute the output of this entire computation that takes map and reduce together. Now Dusk starts executing things. And the way it happens, it starts looking at, okay, what compute resources available? Do I have enough memory? And then sends the next task to be executed to that resource. In my case, the system sees 8 CPUs, and it will start sending those computations of map element first to those CPUs. Eventually, when all map elements are done, it will create the delay reduce, and when the computation is done, eventually it will return the summary file name. Eventually, ignore the close client for a while, for now. I will now go ahead and I'm going to delete the previous Dask demo temp, add it in the past, and I am going to execute the program. If everything goes well, it should work nicely and run 200 times. So currently, again, it created a temporary directory, it defined the functions, it created a compute array, and defined the reduce array. Now, notice, now it's waiting. The next line in the program should say, finished computation. It is now computing. This takes a while. So let me show you how it looks, what happens inside. Oops, sorry, this is the Dask demo. And where did it create the array? Which directory was I? Yeah, I should be in the, have to locate the directory. Let's do it from here. Here, Dask demo temp. You see, those are the batch files. Those are generated by each map element, and they just have echo 1, echo 2, and so on and so forth, up to a random number. Each one of those will be a different random number.
Someone wants to see your CPU usage.
Yeah, this is my CPU. My CPU usage is not very high, and it might be because of two things. A, it might be finished. No, yeah, it's finished already computation. Let's run it again. Here. Now you can see I started running it, and CPU goes up. All 8 cores are working. And let me show you some of the outputs. And remember, we're doing it 200 times. And the errors are 0, meaning that all of the things executed correctly. But you see the outputs are different sizes. Let's look at this one. Here, and you say it just execute echo 0, 0, echo 1, 1, and so on and so forth. I think in Linux it will look differently. So, and you see eventually it stops somewhere. But notice.
Did you pick 8 cores, or was that automatic?
My machine itself, I didn't pick anything. My machine, my hardware, I have a laptop with 4 cores, and each one of them,
I understand.
in,
I'm just asking if you had to set in the number of processes, or if it automatically just uses whatever you have available.
If I didn't define, this is the next thing I'm going to talk about. It's how to define client. There you have a little bit more control, but even with that control, it's a bit more complex. But Dask will try to utilize all your system resources as much as you allow it to. Actually, maybe it's a good part to actually move forward to the next demo. So here it finished again, and it outputted all the files. It tells me here are all the outputs. So it finished the computation again. The output is in summary.txt, and you can actually go and see it. And you can see it's like a long string of all of the output files. Now, usually you won't use Dusk for some simple computation like I'm doing now. Usually use it for something more complicated that you need parallelization in, that takes a long time. Like in my case, I do disease model simulations, then each disease model like looks at the different population. Each simulation looks at different population or a variation of that model, and then it computes it, and all of those things have to be computed in parallel. I run tens of thousands of those processes, and Dusk makes sure that the system is not overloaded. It releases things to computation only when the resources are available. Now, let's go and progress to the next part of the demo. I showed you before. Give me a second. I showed you before. Here it is. I showed you before that I'm using something called distributed. What is this distributed for? This distributed is when you actually run this simulation not on one machine. If you want to run it on one machine, you don't even have to install Dusk distributed. You use the default Dusk client. This is the client that I used here. However, when you use distributed, there are 2 elements that you have to add. You have to add one scheduler to the system, which tells all the tasks when they're scheduled to run. And then you also have to define workers. Each computer that runs everything together has to point to the same scheduler. Let's show you how it looks like. So I'm going to define a scheduler now. What I'm going to do is, this is a Dusk scheduler. Once you install distributed, Dusk distributed, you get this command. It's called Dusk scheduler. I'm going to run the scheduler on my host, my machine. This is my local IP. It's traditional 127.0.0.1 is your local IP. I'm going to run the scheduler. The scheduler has to run on one computer. This is like the computer that organizes everything. The scheduler tells everything when things will happen. It's like the conductor in an orchestra. And now we're adding all of the players of the orchestra. Those are called workers. This is relates to the question you asked before. Notice that I'm opening a different shell, and this shell can be on different computers. Each computer that you want to join the orchestra or the computation has to have the following line. It has run Dusk worker. You point to the scheduler IP. Notice the scheduler has two elements. One of them is 8786. This is the port that by default everything, all the workers and schedulers communicate. The other one is the visualization. I'm going to show you the visualization in 8787 is the visualization. This is how you get to see what really is happening. And you get this for free from Dask. You don't need to work much. It's like once you install and distribute it, you get it. So what's going to happen? Oh, the end prox tells me, cut, I want 4 workers. Each one of those 4 workers will share part of the memory. So I have 32 gigs on this machine. So each worker will have 2 threads because I have, Dask tries to maximize things and figure out how many threads and how much memory each worker will work with according to the numbers. You can actually manipulate them and tell Dask you work with more processes, more threads. You can control it, and there are several other command lines. I won't show it now, but there are ways to actually say how much each computer, how much resources are allowed for each computer. Here it opened 4 workers. Each one of those has 8 gigabytes and 2 threads. Now that the workers are working and the rest and the schedule is working, I'm going to tell my demo to start. You remember, I'll show you the code. Remember at the beginning I defined the Dusk client, and if I provide this as a command line argument here, I ask the distributed connect to that client, meaning I'm telling it connect to that scheduler. So this was the, and I have to tell it 8786. This is the scheduler where you're going to send the computation. This is the first part. The second part, I have to tell it how many times to do it. So instead of 200 times, let's run it 1,000 times. The reason I'm showing it is so I'll have more time to talk while it computes. So it will work the same. At this point, I'm going to run the computation. Hopefully, it all will work okay. And, oh, sorry. I forgot. You also have to do, I'm showing it on Python 3. The base environment is a different environment. It should be working now if everything is set up correctly. Okay.
Jacob, Tom is asking if all it needs is the IP address. Otherwise, it's neutral for the operating systems.
So it's not yes and no. We'll talk about it later. Stick within the operating. You can mix and match. It's a bad idea to do this because operating systems differ in things. But this code with very little changes will run on Linux as well. I haven't tested it on Linux. There might be some funny thing that you'll have to fix, but this code I'm just running on Windows. But when I run my disease models, I run my simulations on this notebook, my initial simulation notebook, and then I move it to my 64-core server, and I'm using the same code. But you need to make sure that your code will run the same on Windows and not. So Dusk will operate on both. Let me show you. If you go to 127.1.1.87.87, you remember when I started the scheduler, it actually allows me to connect through this port, and I'm just opening a web browser and looking at my machine here, 127.0.0.0.1.87.87 is the port, and /status is one of the things it shows me. You see, it shows me how many computations. It tells me you're going to run map element 1,000 times because Python and Dusk already are projecting it and showing this is going to run 1,000 times, and this is going to run 1 time eventually. Currently, I had 227 finished, and you can see the progress bar progresses. However, you get much more information. You get information about your workers. This is all for free. You don't need to pay for it. Once you install Dusk, you have all those capabilities. It shows you all the tasks. And by the way, everything is like it's using bokeh for realization. You actually go and see things, information about things that ran. It shows you all the times and updates regularly. So it shows you how much percentage of the CPU I'm using, how much memory I'm using, which is almost nothing here because this is not memory intensive, but in some cases, think about tasks that run long time and accumulate memory. You can look at all sorts of parameters here, and more importantly, you can see the computation graph. In this computation, it shows you see how many are in memory, how many are processing, and how many are waiting. This task, the reduce task, is waiting. It shows you as a graph. There are 1,000 of those tasks, those map element tasks, and there is one delayed reduce task that is waiting for all of those tasks. The rest, some of them are already in memory, some of them already executed, meaning they finished executing and you have results. These are the reds. The greens are still waiting, kind of, or being processed right now. Once they finish, they become red. And little by little, you'll see this advance. It's like maybe I need to refresh, but it will advance on its own every once in a while. But you can actually see the progress bar here very simply, and you can actually look at other information. While we're waiting for it to finish, if you have any questions, please ask.
Eric asks, he said Celery uses a separate broker like RabbitMQ. Does Dask have the queue management built in?
So you're listening to me. Dask creates the queue for you. This is the graph that you see. You don't even have to declare it. You just tell it, oh, those computations are the things you're doing, and Dask will do it for you.
Yeah, Jacob, what I mean is when you configure everything together, all the functionality of the queue management is built into Dask, because like in Celery you have to use a separate broker. It's not part of Celery.
So whenever
you use Redis or RabbitMQ or something like that.
So Dask is I'm not familiar with those to the details that you're talking about, but notice Dask, the only change in this program with Dask and without Dask, of course, several other things like is the Dask delayed. If I remove the Dask delayed, it will run serially and will wait for each computation. Everything else, Dask automates for you, including the bells of whistles and of actually showing you all this nice visualization of how things are running. And when I run things on the cluster, and you can see most of the computations are done by now, or at least, I know, 60%, 70%. When I run this on the cluster, I cannot show you, but there's a program running behind me that shows me very similar things on different computations. This is all for free. You don't have to work for it. Dusk simplified everything to the point that you don't even have to care about many things. Do I make sense? Yes? No?
Yeah, no. I mean, Celery has the same syntax where you decorate your functions.
Yeah.
To be async. But you have to install your queue management and your workers and so on are separate software that you would choose. So I see that Dask can work with RabbitMQ. I think I was just Googling quickly, but
okay. They work with many systems. I don't know all of the systems, but things that you get if you install only Dusk, it will install the default client, the one that you chose none. Here, if I choose there's no client, it will already come with the client and it will execute on one machine. However, if you want the distributed option, you choose the distributed. This is what I did here. Dask distributed, I imported Dask distributed. This is, and when I set up the scheduler and I set up the workers, this is the backend that does the computation. And notice there are commands I can do it from within Python itself because I do have those I can actually create a whole cluster with one line within using the Dust distributed. I'm not doing it here. I'm doing it manually just to explain that, just to show you how you set those things up. By the way, Dusk has one line that can deploy a cluster. If you create things on the cloud and you have the IPs of the computers that you have, you just do Dusk SSH, tell it where the scheduler is, and it will create all the workers and all the scheduler for you on an entire cluster with one line. Make sense?
Yeah.
Yeah. Okay, let's finish looking at, where is the graph? Ah, it's finished. It's probably finished. Yeah, it's finished computation. So at the end, it reached the computation, and now we can check out that folder. And we should have like 1,000 files here now, and eventually you'll have the summary. Now the summary will be much, much larger, like 1,000 files. Okay. Anyone has?
Jacob?
Yeah.
Sherry was asking what the graph is showing, and like what the triangle was representing.
Okay, let's run it again because I don't know what she was asking specifically. So just run it again and see. And I'll ask questions and I'll try to show as much as I can. By the way, many of the things I don't know what they mean. And sometimes nice thing about it is actually sometimes it shows things in different colors. I noticed like green is usually good, but sometimes it shows me on different systems, it shows me blue bars, it sometimes shows me red. Someone told me from the Dust team that red means IO communication. But if you see a lot of red, then usually it also means that Dusk is having troubles, and every once in a while, Dusk will tell you, oh, you're doing something bad. Maybe you want to improve this. It actually will show error messages. And actually, let me show you what happens in the background. Those are not that. Wait. Here. You see this? This is the workers being, no, this is it. Yeah, this is the workers. This is each time something is sent to the worker, it will eventually show it here. And the scheduler is here.
I
And
think
you
she
can,
was. I think she was referencing the graph that looked like a triangle.
yeah, the triangle. Let's go back. This is this graph. Good.
Yeah, so she was asking what that was.
This is the computation graph. Think about it. In this situation, I had one task that depends on 1,000 tasks. Actually, let's do it simpler. Maybe I'll just kill this, and we'll show you the same graph with less. Okay. I'm not sure it's very good to do this. I'm going to do it only with 100. It'll be quick, but it'll be good enough. And hopefully I didn't mess up too many things. Sometimes all those interruptions mess up the system. You see now, each line here says that this task depends on this task. Can you see the thin lines? Can you?
Yeah.
Yes, I can.
Yeah.
Okay. Here, I'll try to zoom in, but you see thin lines? Those thin lines says that the computation depends, this task, which is the delayed reduce, is waiting for this one. Now, if I had multiple tasks that depend, let's say I ran 5 of those tasks and I had a delay on the delay, then it will show me a much more complex graph.
I had is it possible to have 2 of those tasks that are dependent on the rest of the tasks?
Yes.
Like, so you'd have 2 points?
Yes, I actually do this a lot. When I run my model, my disease model simulation, then I have different tasks depend on different tasks, and some dependencies have to wait backwards and forwards, and you can see all the graph looks much different than here. I'm not sure I want. It's like I can try to show it to you, but it will take quite a bit of setup. So maybe we'll skip this for now. But I can show you the graphs that are much more complex. And Dusk is very strong with this. It will actually remember all those dependencies and execute tasks only when they are ready. I think I'm done with the demo. I'm going to return to the main screen and talk to you guys. I'm going to stop presenting for now. Do you have any more questions?
There was Tom asked if you could save your environment to a YML file and add it to the repository, because he's running it on his end and the performance is not that great.
You're losing me. If I can do what? If he can do something that I'm not doing, or Tom, go ahead, ask a question. Okay, so Sherry, those gray lines mean that there is a connection between one task to another. I'm now seeing the question, so I can answer them. So when the task depends on another, then it will wait for the other, then you will see a gray line. And a task can depend on multiple other tasks. As you can see, like the delay task here was dependent on 1,000 tasks. So it waited for all of those to finish. Tom was asking, oops, I have to go back and Tom. You're asking if you can mix. Tom is asking, if I understand the question correctly, if you can mix systems. I never
believe you
tried.
already answered that one. The one that's still open is the one that he asked at 7:49 with the environments in YML. Yeah, that one.
Okay, so I answered. So can you save environment to YAML file and add it to a repository? Why will you're losing me? What's the purpose of doing this? You can always save things to the YAML file, and you can always later use it later in computation if you need to. In this simple example, what I did is I only saved the working directory, so that this thing can run on multiple machines potentially. I still have to test it on multiple machines. Usually it takes a while more when you start working on multiple machines to configure everything that will work nicely. But Dusk does support it. And I never tried mixing machines like Windows and Linux together. But Dusk will work on Linux and it will work on Windows. I believe it will also works on OS2, on OS X, sorry. I'm pretty sure about that, but double check me. If someone has a Mac that run Dask on the Mac, I'm pretty sure it will work. It's a pretty stable system. However, I recommend stick within the same environment. If you're running a cluster of Windows machines, stick with Windows because the code itself might have to change. Like, directories look different and stuff like that. The paths look different. Some other parameters may change. So this is my recommendation, but I never tried it. It might work. Any more questions, or can we close the demo?
Hey, Jacob, this is Surendra. So you launched the main thread, which was controlling the subsequent threads for the map element. Say if that fails, we have to start it all over, right?
Again, what do you mean main thread? I launched the scheduler.
So
I launched multiple workers.
Right. The scheduler itself, which is controlling the computation on various other systems.
It's like the conductor. It's the conductor of the orchestra.
Right. Something goes wrong with that machine. Do we have to restart it from scratch?
If something happens, if something happens on this
so the scheduling is happening, say for example on one machine, and the actual worker threads are working, but the main primary machine that's having the scheduling goes bad.
Oh, well, you're in trouble. Actually, here, I'll show you. It actually shows you all sorts of warnings every once in a while. You see this thing? This is the schedule. It tells me, oh, there's some problem here. Typically, it's resilient, and even if there are problems, computation continues. I don't know exactly what it is. It's new here. I didn't follow up, but it shows you the schedule. It tells you, oh, I opened up, and then I see all those problems, and so on and so forth. Scheduler reports things happening, and you can actually look at the status of the scheduler through the web browser, but you can actually look at what's happening like this as well. And the workers also reporting stuff, what they're doing. Whenever they execute things, you see the workers are reporting things. So if the scheduler is really bad, then you'll have problems. And by the way, every once in a while you will have encounter problems with Dusk. It happens. Like if you overload the system or overload the scheduler, computations will go bad. I've seen also phenomena. In my case, it's sometimes like files not getting written. And actually, if you look at the Dusk documentation, they actually talk about things like that. Guys, it's been an hour almost. Unless you have more questions, I suggest we stop the recording, or unless you have more questions. No more questions? Okay. In that case, let's stop the stop the presentation. We'll see you all, and we're going to stop the recording. By the way, stick around. Then we continue discussing things even after the recording. We just don't record them. And unless someone has an objection, and unless there's some technical